Hi, my name is William Watson, and today I'm going to tell you about how we use this Airwolf 3D printer to get us to nationals in a rocketry competition. So I am part of the Frog Pond Aeronautics rocketry team, and we are competing in a TARC competition. So the goal is to build a rocket, send it to 800 feet, carrying 2 eggs, and bring them back down uncracked and unbroken. And we need to do the total flight trip in 41 to 43 seconds. So generally when people build these rockets, they'll just use, a traditional foam nose cone, cardboard tubes you can get from a lot of hobby shops, clear plastic transitions, and then for the fins, they will just use, some sort of light wood, and for the centering rings that hold the motor, they will also just use a light wood. So as we got into this and started building, we started running into problems with the parts, especially this transition. So, see, this thing is what they normally use, and it's extremely flexible. I mean, it just has no support to it at all, and it can't hold up to really any amount of, anything. It just crushes. And we were having a whole lot of trouble using it, and it was just causing us a ton of grief. Also on the fins, they're just made out of this light wood, and it just splits like that. And so this is one of our original designs, and you can see a fin broke off here. This fin actually broke off, we re-glued it on. This fin hit and broke off this corner, and we re-glued it on. And I mean, we're kind of eyeballing these to get them straight to begin with, and then after they break and we have to re-glue them on, we can't get them perfect. And so, that causes the rocket to wobble and spin and get a little unstable, and that was causing us a lot of trouble. Also, on these centering rings, they don't have to be that strong, but they do have to withstand heat. And this stuff does fine with heat for about, 3 launches. And after that, it starts disintegrating and losing its structure, and pretty soon we have to rebuild the bottom section of the rocket. So to fix that, we started 3D printing our parts. So this is one of the first things we started on was transitions. So see, I mean, they're real stout. We don't break them anymore. And also, since we're designing and printing, we can customize it. So you see, this one's actually longer than normal, which makes it more aerodynamic and flies better. We lengthen the shoulder, which makes the 2 tubes fit together better. We also added a cross in here to tie our parachutes to, just because we could. It made it a lot easier, it made it fly better. And then for the fins, we started printing our own, so we can make them, the shape we want, the size we want. We can increase the infield to make them heavier, lighter, to help balance it. And, just stuff like that. And then also the centering rings, since we're printing with ABS, they can stand up to the temperature just fine, and so we don't have to replace those anymore. And then also the fins, so we can't glue those on real straight. So we made this slot cutting jig. So the way it works, you slide this tube in, and then you'll do one of 2 things. Either you'll write on here with a pen or pencil, pull it out and cut it, or you'll just cut it directly in this jig. And so you have inch markers written on here to tell what size you want it. And you can actually buy tubes that have the slots pre-cut, but the problem you run into is they only give you their size, one size, can't have any others, and they only offer 3 fin tubes. You can't put 4 fins on your rocket if you wanted to. And also they're more expensive. So after we started cutting them, then we came up with this fin jig. And what it does is it'll slide on your tube, and then you'll stick your fin in, and then it has a little pocket here so you can run your beads of glue down both sides, and you won't glue your jig to the tube. So you just pull it off, your fins are set, they're in perfect thirds, they're straight. That'll take the wobble out of the rocket and make it, a lot more stable going up. So, as we were figuring these things out, we started putting our upgrades together, and towards the end of the year, we challenged ourselves to make a completely 3D printed rocket using all of our upgrades. And that is what this is. So this is where it pops, and then we would have liked to use this rocket for the qualifying, but it was later in the year when we actually came up with it. So this isn't actually our qualifying rocket. But as you can see, this would be the payload tube, and this is the nose cone. So in this particular design, we have the altimeter chamber here and a ballast chamber here. This design, it's just an altimeter chamber. Due to weight purposes, we took the ballast out. And since we're designing these things for this diameter and this height, this is the optimum nose cone. This is a mathematically calculated curve that we did since we're designing this, which is pretty neat. And then also this section, and if any of these parts ever break, we just print a new one and thread it on. We don't have to completely rebuild and reglue our rocket. See, this just threads off. And this year in the competition rules, they make you use a mechanical means of holding the motor in, meaning you can't use a friction fit. So in this design, this motor just slides in here, and then you thread this cap on and that holds it in. And then these fins will just pop right out. So they just slide out. So if you have a windy day and you need smaller fins, you just have an extra set printed. They're a little smaller. You pop them in, you screw the cap on, and you're ready to go. And so that's super convenient, whereas the other way, we'd have to have a new booster section made. But, as I mentioned earlier, this one was designed later in the year. We couldn't use it because we didn't have enough, test launches on it and enough data. So this one was one of our earlier designs, and it has, some of the more important upgrades on it, such as the transition, the fins, and the centering rings. And this is the one that we actually qualified, made it to nationals with. I don't know if you can tell, but back here, we actually used ABS glue to mold those fins into the centering rings to make it even stronger. And so all these upgrades, that's what really helped us, and it made a huge difference. And that's pretty much how we use 3D printed parts to get us to nationals. Thank you for watching.